video, we're going to set our corrective maintenance policy. So we set our pump reliability model, and now we go on to reliability policy, right click. We don't create a new RD because we've already created it, but we open the existing one, so we view the URD, and in fact our corrective task is not being defined, it's not been set, and by default cannot be repaired. But we already prepared it, so we go on to these three dots. We already prepared it, and it's called pump replacement. If we hadn't prepared it, then we will click on this plus and we will create a new one populating all the parameters it requires. So we already prepared it and we click OK. So that maps our corrective task, and we click OK. So now obviously we want to see what's inside. So we go on to pump replacement and double click, and we open up the window, which we would have found, it would have appeared if we hadn't created it already. So our task schedule, start the corrective task upon failure. So we have two choices. We either start upon failure, or if we find it during an inspection. So in other words, the failure is not revealed. We decide to set it as upon failure because the failure is revealed. And then we have the task duration. The task duration is this pump repair model, and we go and see what is actually behind this with a click in the pencil, and it's a variable distribution with 1.5 shape parameter and 12 hours scale parameter. And then we have our maintenance team, maintenance crew. We go on a pencil, and we define the maintenance team cost overall at with a normal distribution at 800 pounds or euro, whatever we want, mean value, and a standard deviation of 250. So the costs are not fixed, but they're variable. We haven't defined a cost per incident. We haven't set a limit to the number of tasks the maintenance team can do. So if there were to occur other failures in other part of our system, they will be able to attend based on this setting. But we put in some maintenance team logistic delay to get to the installation, and that's been modeled with a variable scale parameter of 25 minutes and a shape parameter of 1.8. So as you can see, we can use whatever unit we retain more appropriate, and obviously the software will adapt and convert obviously the unit. And we've included logistic delay and cost in our calculation. And then we go and examine the pool. We have a pool called pump replacement pool, and again what that means behind that, we've analyzed the direct cost to provide a new pump as a triangular distribution that has a mode of 30,000, a lower limit of 25, and an upper limit of 50. Okay, so we use the triangular distribution for that. We don't have any unit available, and the time to request a new one is 3 days. Okay, 3 days with a 1.8 shape parameter variable distribution. And then we click OK, and then the next few things that we need to set. Quantity request is one. Does this task bring the system down? We imagine that the whole more complex system, but obviously it does affect the pump itself. And the restoration is as good as new because we're talking about a replacement, like for like. And final thing, we define also a downtime rate set with a normal distribution of a mean of 12,000 euro, pounds, whatever we want, and a standard deviation of 1800. And that's it.